All right, guys, so welcome back. So I've been spending a lot of time building this new test rig. And this one is truly a maglev. The other one I had would bind up here and here because the two holes weren't parallel or weren't even. And so now this one's really smooth. And I have two opposing magnets down there, and you can see I'm barely touching it. And so that's going to be cool. I'm not done with it yet. Once I finish working on it, I will set up a rotor and test it. I have it on felt pads underneath here, hopefully to stop some of the noise vibration. But that's really nice. This is what I was hoping to achieve. All right, stay tuned. All right, guys, so here's the setup. I really like this new stand. And because it's so loose in here, I get the real effect of a maglev. This thing will spin forever because there's almost no friction. Obviously, there's friction up here at the bearings hitting the side, but it'll literally spin forever. Let me turn it on. Oops, forgot to plug this guy in. And because of that, I can run this at half the voltage. Getting really good output too. This rotor is made from iron infused PLA. I thought I'd try it to see if it made any difference. I have nothing to compare it to. I'll have to print out another rotor that's just plain PLA or PETG. Really smooth. Everything is in line, unlike my other stand, which was just kind of haphazardly thrown together. I should have softened these edges. But if I were to turn it up a little bit, getting really good output. These are nice coils too. They're big dogs. And because it's spinning on the bearings there and there and there, seems to go faster. I can hold this and it will still spin really nice. All right, stay tuned. Yes, as I was saying, this is made out of that iron infused PLA. I don't know that it's probably doing anything. I don't think it may be extending the magnetic flux a little bit, but I've got two 1-inch cube magnets in there. I printed out another one out of the iron PLA with 4. I have those magnets are on their way here. I don't want to excuse me, take apart my other rotors that have the 1-inch cubes in there. But yeah, that's really nice. I really like this stand. All right, let's set up some more stuff and see, because I've got it so that I can do stuff up here too, like I did on my other stand. So I'm going to cannibalize my other stand, take some of the coil slides off of there, and see what we can do. Stay tuned. Another thing that's crazy about this setup is these coils are pretty far away from the rotor, but I'm using Sky Collection's dual JL94 circuit, and they seem to work really well with thick wire. It's running on 7 volts now, so if I crank it up, there's 13 volts. Getting really good output now. Starting to get a little vibration. The camera doesn't do it justice. Let me turn it back down. 7 volts. Oops, let me turn it down a little bit more. Yeah, 7 volts. Yeah, the camera doesn't do it justice. That silver ring is the screws holding the rotor together. In person, it's one solid ring. Anyway, stay tuned. All right, guys. So I got to be careful. So this is a new rotor, and both halves of this rotor are made with the same iron infused PLA that this guy's made of. Now, I don't know if, and this was really hard to get together. These are N52 1-inch cube mags from Total Element. Those guys are great. And this is my new test stand, which you guys have seen. I don't know. This was really hard to put together, first of all. Oh my God. Cut my finger once. I don't know if the iron infused PLA is actually doing something. But it's cool anyway, especially when I went to put this together. The halves, when I figured out how to do it, they just kind of click together because it's metal infused, and it does attract a magnet really heavily. Let me see if I can find one here. Oh, that's, well, yeah, but you guys, I showed you that before. So I'm going to put this guy here and then this guy up here, and then I have the, let me put this down here. Then I have the coils that have the metal infused PLA. I have the cores for them. I'm going to use those for pickup magnets up here. I have to mount these guys. These are slides for the coil. That's what's so cool about 3D printing. Put that there, put the coil in there, slide it in there. And because this is a new stand, the maglev part is really good. My old one was too tight between the two bearings. And I think I had too many bearings in there too. I had one up here, one under here, one there. I just have the two in there. Anyway, let me get this guy mounted and we'll go from there. Stay tuned. There it is. It's cool because they can spin independently. I could spin that one that way and that one that way. Not that I would do that. But they're far enough apart so there's really not a lot of interaction. I really want there to be, well, I guess there is a little bit of interaction. It's kind of heavy, so it's really the maglev part down here is pretty close, but still there's a lot of power between those two magnets. So now I got to get these coils situated. Yeah, I got to learn to handle magnets more carefully. I always end up hurting myself. I like that. That's cool. Again, I don't know if the iron infused PLA is actually adding to the magnetic flux or if it's, I'm not really sure if it's doing anything. It might be. All right, stay tuned. All right, so I got it going. It's going nice too, really smooth. So 12 volts coming in. The pickup coil is not really doing much. I'm getting about 4 volts off of the pickup. I have it going through a bridge rectifier down here. right here, going over to my Gosa Fix or Gotcha Fix, whatever you want to call it. I didn't think I was going to get much out of these guys here. I'm going to put my other pickup coils up there. If I take out the... Yeah, it doesn't really make much difference even with the... So these guys don't really add anything to it. I would have to put actual, like this guy in here, which is, this guy has potted BBs in there. Yeah, and that really increases the voltage. Yeah, that increases it by a couple of volts. I don't know if you can see it. It's getting about 6.5 volts with the, let me take the shim off of this thing. It's hard to get it in there because it, there it goes. Yeah, so that does increase it. So the experiment with the iron infused PLA didn't really do too much as far as increasing the coil output. Because if I take these guys out, which these are real iron cores, because they have actual iron in them. Take these out, drops down to, yeah, like 4. If I put these in, yeah, so these guys don't do much, unfortunately. I was kind of leery. I didn't think it was going to do that much. But this guy's going nice, though. All right, stay tuned. All right, guys, so I'm making some more attachments for this new shelf. Here's a one that's going to hold this size. Come on. Come on. Oh, that's because, yeah, I got to do it on this side because I have those things. So it goes like that. And then, of course, it'll slide into here. Well, yeah, you guys get the gist. And then this part, this is why I love 3D printing. This part will go in here and probably get screwed down the same way I screwed down the side braces here. Probably put one there, one there, and one there. Countersink it. So yeah. And what I'm also going to do is I'm going to change this up, even though I like this setup. Oh, and I don't know if you can see, I put more magnets down here because this was kind of heavy. I mean, it was still working okay, but I've got this guy I want to put back on there. Whoa. But I also want to, oh, come on. I also want to, where's my crystal clear one? It's around here somewhere. The one that PCB Way made for me. That clear acrylic. I'll find it. Yeah, I want to put that one up top here. The clear acrylic one. I want to put that up top. Come on. Take this out. Sorry about that. What a freaking mess. Yeah, so I want to put it's a 3-prong one. I want to put the clear acrylic one up here. and then maybe keep this one down here. And I want to take these big coils out and mount these guys in there. Yeah, I got to find the clear acrylic one. What I also want to do is fire up a couple of my older pulse motors, like this guy right here. That guy's pretty cool. And then my maglev over there. Anyway, let me get this guy all set up. Stay tuned. All right, so I went ahead and changed everything around. I've got the one that PCBWay made for me out of the translucent acrylic. I think that was done with SLS printing, which is really cool. And then I have my 4-prong one with the big coils on here. And then I decided to use my old reliable coil holders. These things are self-mounting. See, they slide right off and I don't need to do anything. I just slide them on like that, and then I can slide them like that and then put a coil in there and adjust it that way. Yeah, something like that. So what I'm going to do is I'm going to put the 2 big coils in here, but I'm going to run the system from this small coil, from this small rotor up here. And again, they're all freewheeling, so they can do whatever they want to do. All right, so stay tuned for that. So it's kind of like that. But I'm going to obviously put another coil up top here to run this small one here, which will hopefully run the big ones, and I can see what kind of power I'm getting out of these big coils. Probably it should be decent, and I can actually push these in even further so that the magnetic flux is inside the coil itself. I don't know. I'll have to check it out. Let me see how far I can push these in without it hitting. Yeah, I can go even further. That's probably what I'll do. See, these slide in and out like that. Yeah, that'll work. All right, stay tuned. All right, so I've got it going. I haven't hooked anything up yet to these guys to get any type of output, but it was tricky getting this guy up here because it'll work now that it's connected, but I had to get it started by pushing it close together. But once it gets connected, then it's good. Works better though when it's closer like that. This thing's got a little bit of a wobble. It's not really balanced, but come on, it's plexiglass, acrylic and 3D printing. But now I'm going to hook something up to these guys and hook it up to a bridge rectifier and see what I can get out of it. But let me get it going. Stay tuned. All right, guys. So I got the big dogs hooked up. These big coils put out a lot of power. I got 12 volts coming in, and already I've got over 20 volts going out. But that's just voltage. That's not power. But yeah, 24 volts going out through this bridge rectifier. This little guy is running this big guy. And you can see over there 27 volts. And I can actually now move this out like that and it'll stay catched. 26 volts. Yeah, so about 25 out. So each of these is probably putting out, 12 or 13 volts. I could hook up my other meter, which supposedly can also tell me what the amperage is. I know how to measure amperage. I don't feel like setting up for that. Let me put this in closer. That'll speed it up. And when I speed it up, that guy increases. Little maglev power going there. So not bad. Kind of cool. All right, guys. Thanks for watching.